Okay, rational expressions, fractions. So we got to remember all our rules about fractions and how to simplify. And we're going to throw variables in there today. So we've got to state the excluded values. And we'll talk about what those are and why we need those and things. So let's start off with the elementary school kind of problem and talk about how do we simplify 24 over 56 and why do we do it that way. So how do we simplify that fraction without just typing it in the calculator and telling it to do it? Okay, it's 2. 2 goes into 24, 2 goes into 56. Is that the biggest number that goes into both of them? No, so we could take out more than that, right? So what's a bigger number that goes into 24 that goes into 56? 8 goes into 24 how many times? 8 goes into 56 7 times. So in our mind, we're thinking this step. I'm writing it out here so that we can see what's happening. But we think that we just divide that number by 8 and get 3. Divide 56 by 8 and get 7. That's how we simplify fractions. What we're doing there really is canceling out matching factors, because factors are things that are multiplied together. So we're canceling out matching factors. In our case, the matching factor is the 8. So that reduces down to 3/7, just out of that. This one does not have excluded values because there are no variables in the denominator. Excluded values comes from a variable in the denominator. Because what's the only number that we cannot divide by? That it's undefined to divide by this number. No, you can divide by pi. 0, can't divide by 0. That's one thing we can never do, is divide by 0. If I ask you to take this piece of paper and divide it between 0 people, that's impossible to do. But if I ask you to divide it between one person, all I gotta do is just hand you that piece of paper. Divide it between 2 people, cut it in half, hand it to people. But I can't cut it into 0 pieces because it's one piece already. So that's why I can't divide by 0. So simplifying fractions or rational expressions, we're going to cancel out matching factors. So guess what we got to be able to do? Factor polynomials. So we'll step our way into that as we go along here. So let's get one that's got variables involved. So when we're simplifying and stating the excluded values, you want to find your excluded values before you simplify. Okay. So to find the excluded values, we're going to abbreviate those as EV. The excluded values come from the denominator because that's where we could divide by 0. So we're going to take the whole denominator and set it equal to 0. So 16x equals 0. And then solve that problem. X is equal to 0. So the only excluded value we have for this problem is 0. X can't be 0 when we do that. This is going to be more important when we get to the equations step, when we're solving equations, because we find answers, and if they match excluded values, we have to throw them out, kind of like we did with the logarithms. Now, the next thing to do after you find your excluded values is actually simplify the thing. So we're going to try to break down that 12 and the x squared and the 16. So what do we know about a factor that goes into 12 that also goes into 16? 4 is the biggest one. That's 4 times 3, and then 16 is 4 times 4. What does x squared mean? And x times x, right? And then cancel out the matching factors. 4 is a matching factor. So this 4 cancels that 4, and then I don't have any more 4s to cancel with. So this 3 and this 4 are still in the answer. How many x's cancel? 1. On top, 1 on bottom. That leaves us 3x over 4, or you could write it 3/4 x. Either of those. This is the way I normally write it, is that way, but you could write it the other way if you wanted to. Okay. So real small kind of problems here. Let's say we had 21x squared over 42x cubed. Let's kind of maybe shorten up the number part of it, because we know how to do the number part of it. So greatest common factor between 21 and 42. 21 is bigger than 7. 21 goes into itself. 21 goes into 42, right? So that's the greatest common factor. 7 would work. It'd get it broke down a little bit, then we'd probably see that, hey, 2 goes in, or 3 goes in both those as well. So 21 is going to cancel out and become a what? 1. Y'all remember doing it this way. Probably more, not 21, but 2. All right. And then what about our x's? 2 of the x's cancel out, leaving 1 where? On the bottom. There's more of them on the bottom, so that's going to be a 2x on the bottom and just a 1 on top. And if it helps you to write it out and then cancel, that's how it's happening. Some folks, first plot, we're talking about exponent rules. What's the exponent rule when you divide? Subtract. If I subtracted those two, what's 2 minus 3? -1. If you do it that way, you've got to remember, I can't leave a negative exponent. I got to move it to the bottom. That's how the x ends up in the bottom out of that. Both ways work, and you get it the same answer that way. But keep in mind all of that stuff going through there. We didn't do excluded values, though. We forgot to do that. Let's do those. Go back to the original. What's the only thing that x could not be? 42 times what gives me 0? 0. 0 is the only number I can plug in for x and make that equation work. So the excluded value for that one is 0. Remember, we want to do our excluded values with the original denominator, not the simplified one. Okay. Doesn't really matter much on the last couple of problems, but when we get to larger polynomials, it will. It'll be an important thing. Okay. So matching factors are what we're canceling out. And then getting our excluded values before we do that. Let's look at this one. 3x parentheses x plus 4 over x plus 3 parentheses x plus 4. And before I forget, write EV over there so I remember to find my excluded values. So in order to find my excluded values, what do I do? Set the denominator equal to 0. So I'm setting the factors x plus 3 times x plus 4 equal to 0. And then what do we do with each of those factors? Solve. Set those equal to 0 and solve. Y'all know the answers to that. -3, -4. We've done a lot of that lately. Okay. So we have excluded values of -3 and -4. Now, our polynomials are factored already for us in this problem. So what's the matching factor? X plus 4 matches that x plus 4, and it cancels out. Now, the other two pieces, this 3x is a factor, and x plus 3 is a factor. They don't match. Even though they got the same letter and same number in them, this is tied together with multiplication. This is tied together with addition. So they're not the same. So you cannot cancel a part of a factor. You can only cancel whole factors. And so x plus 3 is a factor. 3 is a factor. X is a factor. You can't cancel parts of that. So the final answer is 3x over x plus 3. If it's got addition or subtraction in it, then it's got to match exactly to cancel out. You can't cancel out parts of that. I cancel the whole thing or none. Okay. So those were already factored for us. Let's do one that's not. X squared minus 2x minus 15 over x squared minus 5x. Again, I'm going to find my excluded values before I simplify. So I'm going to set the denominator equal to 0. And when you're trying to find your excluded values, your first instinct should be to factor that denominator, because you're going to need that factoring later on to be able to simplify the fraction anyway. So let's make sure that you're factoring that denominator in order to solve it. All right. So how do we factor that? Greatest common factor is x, and that would leave what in parentheses? X and x minus 5. And now we set x equal to 0, x minus 5 equal to 0. There's one of them. The other one's positive 5. And because I used factoring for that, I've already got the denominator factored. All I got to do is go back and factor the numerator. It's a trinomial, so I know I'm going to do that x method thing. And multiply to be negative 15 and add to be negative 2. Be x minus 5 and x plus 3. Right? And then what factor cancels out? The x minus 5. X plus 3 over x. That's it. Yeah. So factoring is going to be a big part of this. If you weren't great at factoring, better get great at it. Go to my YouTube channel and go find all those videos about factoring. We did a lot of it this year. So you got to be able to do that to do this. X squared plus 2x minus 15 over x squared minus 25. Excluded values. And everything inside of me wants to solve that by square roots. But I know that I'm going to need the factoring of it done anyway. I would normally add 25 and then take the square root of both sides to solve that. But I want to get the factors because I know what I'm doing is simplifying a rational expression. So I'm going to do the factoring because that's a what? Difference of squares, x plus 5, x minus 5. Get x equals negative 5, x equals positive 5. You could write that as plus or minus 5 if you wanted to. The same thing. So then I look at my fraction. I've got the bottom part already factored. And let's factor the numerator. What are the factors for the numerator? X plus 5 and x minus 3. And then what cancels out? Yeah. X minus 3, x minus 5 is our rational expression. That's the final answer out of that. And this one's the last couple have been good examples of why you do excluded values before you simplify. If you waited until you're done simplifying, you only have one thing left in the denominator, so you would lose one of your excluded values. So you've got to do that excluded value before you simplify. You make sure to get all of them, all of the numbers that would have gotten the original problem to have a 0 in the denominator. Okay. $40x squared plus 20x over 10x plus 30. This one kind of threw some of the first part for the it doesn't do as much as you'd think it would. Say it again. Okay, yeah, if we factor the top. But before we do that, let's find our excluded values. And we'll go back and do that. Do we normally solve that kind of equation by factoring? No. So don't. Just solve it. Worry about factoring in a minute. So that'd be 10x is equal to negative 30 divided by 10. X is negative 3. Now, let's go back to that factoring. The top part, you said the GCF was 20x. And that leaves 2x plus 1. Now we got to think about factoring because we don't normally solve that by factoring, but when we're trying to simplify a rational expression, we do want to think about factoring. So how can we factor this thing? A GCF of 10, that's right. Pull out a 10. That's going to leave us x plus 3 in the parentheses. Now, okay, so these two pieces are both divisible by 10, right? So we could cancel that part out, and that would leave us 2x and 2x plus 1 on top, and then only an x plus 3 in the bottom. And that's all you can do on that one. There's nothing else that cancels out. So you're just looking for pieces that can cancel, not necessarily always going to be things that factor that way. All right. Now, let's look at one's a little tougher. X squared plus 6x plus 8. So a nice little trinomial on top. And that fun thing on the bottom. X squared plus 6x plus 8 on top. X cubed plus 64 on the bottom. So again, we're going to find our excluded values. So x cubed plus 64 is equal to 0. So again, what should our first instinct be when we're trying to find excluded values? No. Supposed to be factoring every time. How do we factor x cubed plus 64? It's a sum of cubes. So that means it's going to have a short factor and a long factor. What's the short factor? X plus 4. The long factor. X squared be minus because it's always opposite. And then the last term would be plus 16. All right. Now, what do we know about the long factor on a sum or a difference of cubes? It'll never factor. That's exactly right. So that means in order to solve this, what do we have to do with that quadratic that's there? Quadratic formula is what we're going to have to use to solve that factor. Because we know that the long factor from a sum or difference of cubes doesn't factor. The other one, that's easy. That's x plus 4 is equal to 0. We get negative 4 as an excluded value. This one, we're setting that quadratic up and doing quadratic formula. So that'd be 4 plus or minus. And then we do the discriminant. So negative 4 squared is 16 minus 4 times 1 times 16. So 4 times 16 be 64. So that'd be 16 minus 64, which is negative 48. And over 2. What do we know about the answers to this? Don't be complex because that discriminant was negative. And so we're going to simplify that. So that'd be negative, or it'd be 4i radical 3. And then we can simplify that just a little further. It'd be 2 plus or minus 2i radical 3. So we found all 3 of our excluded values. 2 of them happen to be complex, but that's okay. Still want you looking for those. And now we're going to factor the numerator. We've already got the denominator factored. X plus 4, x squared minus 4x plus 16. How does the numerator factor? Yeah, x plus 4 and x plus 2. Multiply to be 8, add to be 6. That'd be 4 and 2. And then what cancels? Those two. And we're left with that thing. Factoring is the name of the game here, guys. All right. Let's try this one. 5x squared minus 10x minus 15 over 2x squared minus 2x minus 12. Excluded values, so I got 2x squared minus 2x minus 12 equal to 0. And my first instinct should be to do what? GCF of that, which would be a 2, leaving x squared minus x minus 6. And then I'm doing the x method on that, negative 6, and I had to be negative 1. And be negative 3 and 2. What happens to the 2 in the solving step here? Yeah, technically you divide it and it goes away. And you get x minus 3 equals 0, x plus 2 equals 0. And you get 3 and negative 2 are our excluded values. When I go back up here to do my simplifying step, the factored form, you got to have that 2 in there. It went away when we were solving, but in the factored form, it's still there. So make sure that you keep it there. How do we factor that numerator? All right, yeah, I'd factor a 5 out, and that'd leave me this. And then I'd do x method on that. So negative 3, add to be negative 2. Negative 3 and 1. So we got a 5, x minus 3, x plus 1. Pretty easy to cancel there. That's all it cancels. So the final answer is 5 parentheses x plus 1 over 2 parentheses x plus 2. And just leave it in that factored form there. You don't have to multiply it back out for me. Yeah, it's a good bit of work for one problem, but it's not, you know, I don't think it's as long as some of those polynomials we were doing back last week, you know, to be honest about it. So, all right, let's look at one more simplifying, and then we'll get into the multiplying. 2x squared plus 10x divided by 3x squared plus 16x plus 5. Let's get our excluded values. So 3x squared plus 16x plus 5. Well, I hope it factors. Multiply to be 15, add to be 16. 15 and 1, it does factor then. So I can't do the shortcut on this. I gotta put the other stuff in there and group. Group the first one, x is the GCF, 3x plus 1 left over. Second pair is plus 5, 3x plus 1. So our factors are x plus 5, 3x plus 1. And what do we know our excluded values would be then? -5 and -1/3. So I'm going to factor I've got the factored form of the denominator. It's x plus 5 and 3x plus 1. What do I do with the numerator? Which is 2x. That leaves x plus 5. Cancel out the matching factor. And there's our simplified form out of that. So again, factoring is a very important skill. I wonder why we spent a lot of time doing that earlier this fall. We spend a lot of time, or spend a fair bit of time in Algebra 1 trying to learn how to do that. So good experience factoring is key to this. All right, let's get into the multiplying and dividing part. And I think we all have the idea of how to find an excluded value. Take the denominator, set it equal to 0. So when we go to do the product and the quotient, I'm not going to make you do the excluded values on those, okay? We'll need to do them when we do the equations later on because they have a purpose. But for products and quotients, I'm not going to make you do excluded values. So we'll skip that step here. And even on the homework, you don't have to do it. So excluded values, denominator is equal to 0. So find the product. Product is multiplication, right? So we're going to multiply 3 over 28 times 21 over 18. And let's just talk about the rules that we learned and hopefully know how to follow for multiplying fractions together. And what are the things that you're allowed to do when you go to multiply those two together? I can simplify in what directions? All right, so that's diagonally, right? 3 and the 18. Diagonally, 21 and 28, you got something we could do with those, right? What about 21 and 18? Could that be simplified? Yeah, they're both divisible by 3 at least. So you can, the ways that you're able to cancel things out are vertically or diagonally. Never side to side, but either vertically or diagonally. So the way that I like to do that is to think about it as, okay, 3, or I like to do vertically first. So 3 goes into 21 and 18. And so that'll break that down into 7 and 6. So I did that vertically. And then I do diagonally. It technically does not matter what order you do it in. That's the way I do it. Diagonally, 7 goes into itself once, and then 28 4 times. 3 goes into itself once, and into 6 2 times. Now I have 1 times 1, 4 times 2, get 1/8. So regular fraction multiplication, same rules are followed with polynomial fraction or rational expressions. You can simplify vertically or diagonally. That's the only ways that you're allowed to do that. Okay, so let's look at one that is more Algebra 2 speed. So there's a fraction, rational expression, excuse me, same thing. X squared minus 16. And then the bottom is 5x on that one. So we got two fractions, x squared plus 4x over x squared plus 8x plus 16 times x squared minus 16 over 5x. Okay, so, excuse me, as we're trying to simplify this, guess what we got to do to everything? Factor it. Okay, so factor everybody that'll factor. So I'm just going to start with the first fraction, the numerator. How does it factor? Pull an x out. That leaves you x plus 4 in parentheses. The denominator. X method for that because it's a trinomial. Multiply to be 16 and add to be 8. 4 and 4. So that'd be x plus 4 and x plus 4. And I usually will write it out, both of the x plus 4s, and not write it as x plus 4 squared because I know I won't do that till the very end if it shows up there. Okay, because I'm looking to cancel things. And then the second fraction, the numerator. Yeah, it's a difference of squares. So x plus 4, x minus 4, and then 5x really doesn't do anything. So which ones? Diagonally? Okay, so this one cancels one of those. There's an x plus 4 vertically that can cancel each other out. So it's a one-to-one cancellation idea. What else could cancel? Yeah, that x and this x can cancel each other out. What's left? X minus 4 and over 5. Boom. Well, they're parts that are multiplied together, not parts that are separated with addition and subtraction. Okay, so this x and this 5, this x here, this is 5 times x, so it's multiplied together. So 5 is a factor, x is a complete factor. To cancel out any of these others, they had to match perfectly with the x plus 4 because they had addition and subtraction in them. If they have addition and subtraction, you can't do parts. But if it's multiplied together, you can do parts. Hopefully that makes that kind of makes sense. I hope. Anyway, that's a hard thing to deal with. So 5x squared plus 20x over x squared minus x times, bless you, x squared plus 3x minus 4 over, let's just throw in x squared minus 16 again. Something we're fairly familiar with. I think it worked out pretty easy. So if we were going to have to do excluded values, you would have to do both the denominators. You'd end up finding 4 excluded values for this one. But I'm not making you do that. I think you got the idea of that. That's we'll do plenty of that when we do the solving. Okay. So get to factoring everybody. Start with the first fraction. Top part, numerator. What do we pull out of there? Negative 5x. So whatever, if you've got a polynomial and the leading coefficient is negative, you're pulling out a GCF, pull that negative sign with it. And that'll leave x minus 4 in the parentheses. And then the denominator of that first fraction, the x minus 1, right? Second fraction. I'm going to do the bottom part because we already done that once today. So that's easy. What about the numerator? X plus 4, x minus 1. Good job. All right. Then start canceling stuff. I got vertically, x plus 4 is canceling. Diagonally, an x minus 1 and an x minus 4. Gosh, a lot of stuff canceling. And then vertically, I got x and x. They cancel each other out. What's left? Over what? Technically, it's over 1. Do we have to write it over 1? No. That big ugly problem turned out to be negative 5. Is all it really was. That's nice. X plus 2 over x cubed minus 27 times x squared plus 3x plus 9. That's it. Is it? Good question. Is that a question? Or it's a statement. Okay, because it had the inflection of being a question. All right, so it is over 1. If it doesn't have a denominator, it's over 1. If it doesn't, if there's nothing left on the numerator, there's a 1 up there. If everything in the numerator cancels. So, got what kind of factoring can happen here? I got a difference of cubes down in the bottom part because it's 27 is what cubed? 3 cubed. So we got to factor that way. Short factor, long factor. Top part of that fraction doesn't factor. So what's the short factor? Be x minus 3. There's difference of cubes, so it's a minus. And then the long factor. Nine. Good job. Now, what do we notice about that piece? It's the same as that one up there. Does that one up there factor? It doesn't matter. That's right. It doesn't matter. So the factoring, it won't factor, but it doesn't matter if it does or not because it cancels out just right away, just as in its trinomial state. So then we get x plus 2 on top, 1 times x minus 3 on the bottom. It's just x minus 3. It simplifies to that. Not too bad. Pretty good. No problem there. Let's do another product here. X cubed plus 8 over x minus 2. X to the third plus 8 over x minus 2. And the second fraction is x squared minus 4 over x squared minus 2x plus 4. No. Sum of cubes. Got a plus sign in it. So I know that one doesn't factor. So short factor, long factor. Good. Good job. And then the top part of the second fraction is the difference of squares. Plus 2, x minus 2. Oh, yeah, it doesn't even matter what happens on the bottom. They're going to cancel. So top part has x plus 2 and x plus 2. They can't cancel because it's sideways. Remember, we can only cancel vertically or diagonally, never side to side. So x plus 2 times x plus 2 or x plus 2 squared. What's in the denominator technically? 1, because everything else canceled out. But we don't have to write it over 1. Let's flip that way. Okay? So multiplying just takes factoring, cancel out vertically or diagonally. Let's look at quotients. So go back to elementary school and think about how in the world do I divide 12 over 25 by 4 over 5 without using the calculator? Of what? The second one. We flip the second one. So it's 12 over 25 times 5 over 4. And then same old rules. Did you not check in with her? Last thing I think is them yelling at me about something. All right, so cross cancel 4 and 3, 5, 1, so 3/5. So division, it doesn't change the rules any, just we got a 1 extra step. So let's do one problem like that and then we'll be done. 7x over 2x minus 10 divided by x squared minus 6x over x squared minus 11x plus 30. So flip the second one. And multiply. All right. Same old rules. Factor, cancel out. So 7x, 2, x minus 5, x minus 6. And I'm going to do x method on the 30 and negative 11. What multiplies be 30 has to be negative 11. Negative 6, negative 5. It'll be x minus 6, x minus 5. All that mess to get 7 over 2. So, not just